We're going to discuss about the number of non-isomorphic spanning tree of a complete graph of with m vertices. So the spanning tree is basically a tree for a given graph. The definition is that it is a subgraph of G that is a tree and it contains all the vertices of G. It is very useful because it is a sparse representation of the tree and is helpful in some routing or routing algorithm. And it is also used in problems like Steiner tree problems and traveling salesperson problem. And we'd like to, and the second definition is a complete graph denoted by Kn. A graph is said to be complete if every pair of distinct vertices in the graph G is connected by an edge. So the Cayley's formula, which we will prove in the future, says that the number of spanning tree in a complete graph Kn is n raised to the power of n minus 2. In fact, this is the number of the proof sequences of length n minus 2. We later will prove the bijection between a proof sequence and a spanning tree. For example, a complete graph of three with three vertices can be shown here. By the Cayley's formula, there will be 3 raised to the powers of 3 minus 2, which is 3 spanning tree. But let's note that there is only one non-isomorphic spanning tree. Non-isomorphic meaning that if we remove the label, or you can just call it non-labeled spanning tree. If we remove the label and after some twitch and stretching, they are not the same, then it is called non-isomorphic. If we, after removing the label and after some twitching or stretching the tree, they become the same, then they are called isomorphic. This is a basic idea. Similarly, we can, for a complete graph K4, we can calculate by the Cayley's formula, there are 4 raised to the power of 4 minus 2, which is 4 square, which is 16 spanning tree listed here. But if we look carefully, there are only 2 types or 2 non-isomorphic trees here. The 4 trees enclosed by the red rectangle are all isomorphic, and the remaining 12 trees are isomorphic. So there are only 2 non-isomorphic spanning trees here. For graph 5, we can the non-isomorphic trees are the number of non-isomorphic trees are 3, and for 6 K6 there are 6 non-isomorphic spanning tree, and the number listed here, you can visit this website https://oeis.org. It is the A000055. This is called the number of trees with n unlabeled nodes. And it also provides some recurrence formula for for deriving the Caveton term. And if you are interested, you can visit this website. And that's it.